So this talk is called Building a Better OpenStruct, and that's what I want to talk about today. But I can't really talk about building a better OpenStruct without first talking about, like, what is OpenStruct? How does it work? What are the problems with it? And why would we want to build something better? I like to think of OpenStruct as Ruby's JavaScript object. And you'll see what I mean in a second. So you can require OStruct anywhere in your code. It's part of Ruby standard library, so it's always available. You can create a new OpenStruct, either just OpenStruct.new, just create it, or in this case, what's more common is you just pass in a hash. Okay, so we have a key of foo and a value of bar. Once it's created, you can set properties in really two ways. One is dot notation, like OpenStruct.bas equals 4. And the other way is to use bracket notation. Okay, so we're setting something to whatever. You can use, the value can be anything, and the key has to be either a symbol or a string, basically. When you want to get values out of your OpenStruct, you can use dot notation like this. So whether it was set at initialize time or later on with dot notation or bracket notation, comes out just fine. And if you try to access a property that has not been set on the OpenStruct, it'll just return nil. You can also use bracket notation. So again, you're basically putting in properties, taking out properties. It's a nice value object. And you can use, again, these two kinds of notation, very similar to how in JavaScript, right? You can set and get properties using either dots or brackets. So I like to think of it as like a JavaScript object, but in a different language. So that's nice, but why would we want to use it? So there was a great talk at Rails Israel last year where Eric Michael Zober identified 3 common use cases for OpenStruct. So this is his list. We're going to show some code examples that are my code, but it's his list, and I have to give credit where credit is due. So this might be the most common use case, certainly in your applications, is to consume an API. So here's how that might look. You make an API call, you get back some JSON, parse that out into a Ruby hash, and then you just create a new OpenStruct with that hash. A more complex pattern that you can follow, and we do this a lot in our applications, is you actually subclass OpenStruct, and then you pass your parsed out response into a new instance of that class. So what's nice about that is, let's say you're, hitting the Twitter API, and you get back information about a tweet. So instead of having just kind of a raw hash, or the simple strategy that OpenStruct, instead you can have a tweet object that's holding these properties. So let's flesh that out just a little bit more. Let's say this is our API response. We have a couple keys, a couple values. So with an OpenStruct, instead of just using bracket notation like you would if it was just a hash, if you pass it into an OpenStruct, you can use dot notation instead. So you can start thinking about your data more as an object than as just raw data. What's really cool is if you follow that advanced version, you can actually start defining your own methods. So in this case, let's say we have an API call that gets us a user. We can define a name method, which will just concatenate first name and last name. And from the outside, first name, last name, and name, you don't know which is a property and which is a computed value. And that's kind of the point, right? Objects, message passing. So these are kinds of the basics of object-oriented programming. We can treat our values as real objects. We can have encapsulation, and it's really nice. Case number 2 is a configuration object. So let's say you have a gem, and you want to configure it using a DSL like this. So right at the top, you're going to call .configure. You're going to get a block which takes a configuration object, and then you can just start setting settings on your configuration object. This is all the code that you need to implement that. So you have your configure method on your gem. It yields a configuration object, which is just an OpenStruct that you're going to hold on to. And with an OpenStruct, you can set and get attributes, whatever you want, totally arbitrary, and it just works. Case number 3 is a little more complicated. Uses a test double. So let's say you have an order class which takes a payment gateway and some products, sums up the total cost of the products, and it charges the payment gateway. If you actually pass in a real payment gateway, this is going to get really expensive to test, because you have to put in someone's credit card, and every time you run your test suite, someone's credit card is going to get charged. So we don't want to actually use a real payment gateway. We want to use a test double. So OpenStruct makes that incredibly easy, because any key and value pair that you define is going to become a method and its return value. So if you define an OpenStruct with a key of charge and a corresponding value of, let's say, the symbol paid, so if you call .charge, it will just return that value paid. and you can run your tests. You can assert that a value is returned. You can assert that values are set on the OpenStruct. It's really nice. It's really simple. And no fancy gems, no libraries required. It's all included as part of a standard Ruby installation. Let's take a look at how OpenStruct works. And before I move on, I just want to warn you, I have brutally edited all the code in this presentation, not because I want to lie to you. Maybe I do. But mostly because there's a lot of error handling and all kinds of other edge case kind of things that we deal with, and I wanted to take away the messiness and just focus on what's happening. So optimizing for understanding rather than fidelity to the originals. But everything here is open source. Everything you can look up and see how it really works in all its glorious detail. So what's going on in OpenStruct is it's defining methods for setters and getters on the object's Singleton class. Now, Singleton classes, I know people often get confused about. Some of you might not be familiar with them or might have forgotten, so here's a little refresher. In Ruby, if you have an object, let's say it's called foo, you can define a method, in this case bar, that's just going to exist for that one object. So no other method in Ruby shares that method. We can call foo.bar and it comes back just fine. And if you call foo.singleton methods, you'll see that that bar method has been defined, again, as a singleton method. And any other object in Ruby will not have access to that method. So the reason we talk about singleton classes is under the hood, what's basically happening is every object in Ruby has a class that exists just for that one object. So that's where the methods really live. But again, that's complexity that's not necessarily relevant to us right now. You can think of a singleton method as a method that's just for one Ruby object. OK. Now let's kind of look through the life cycle of what happens when you create an OpenStruct and set and get values. So here we're creating a new OpenStruct with a key of foo and a value of bar. Okay, we'll keep it simple, just one key value pair. So it's going to hit initialize. The first thing that we're going to do is set an @table instance variable to a hash. And watch that @table. That is where all of our information is going to be stored. Any keys and values we're setting are just going to be going right into that table. So then we have our input hash, our input arguments. And for each pair, we're going to convert the key to a symbol. And then we're just going to set that key and value pair inside of our @table hash. And then something really interesting happens. We call new OStruct member. And I'm going to tell you what that is in a moment, but I want to look at something else first. What happens when you set a property on OpenStruct with dot notation? OK, OpenStruct.baz equals 4. The first thing to realize is that in Ruby, this is just syntactic sugar for calling the baz equals method with an argument of 4. Okay, anytime you see .baz space equals space 4, it's just calling baz equals with an argument, one single argument of 4. Well, we don't have a baz equals method, so we're going to hit method missing. And what that's basically going to do is check, is this a setter or a getter? So if we're trying to set something, if it's an equals method, so we're going to chop off that last equal sign, and we're going to take the rest of the method name, which is baz. We're going to call new OStruct member, again, with that method name baz. That's going to return the symbol baz. And then in that table, we'll set baz to the first argument, which is 4. So basically, in our table now, baz is set to 4. Pretty much what you'd expect. On the way out, we call .baz. Again, that method doesn't exist. And we're just going to fetch it out of the table. Okay, so we're at table, open bracket, baz, close bracket. That's what's happening there. Now let's talk about that new OStruct member, because that's kind of where all the magic happens. So the first thing that we do is coerce the name to a symbol. Then we check, do we already have a baz method? If so, then we're just going to move on. We don't want to override any methods that you've already defined. But let's say we haven't, which is going to be the standard case. So we're going to define 2 singleton methods, right? 2 methods just for this one object. So one is a baz method, and 2 is a baz equals method. The baz method is just going to pull the value for baz out of the table. And the baz equals method is going to set baz in the table to whatever is the argument to that method. So it's kind of like add a reader, add a writer, the things that you use in a standard Ruby class. But the main difference is instead of using instance variables, what it's doing is setting and getting values on that internal table. So that's how OpenStruct works. And it also means that no 2 OpenStructs share a set of methods. Even if they look the same, they have the same attributes, but they're still gonna technically be having different methods, right? Those methods have to be defined every time on every individual object. Now here's the problem with OpenStruct. OpenStruct is really slow, and you might be wondering, like, okay, but how slow could it be? So I'm going to ask my friends the snails, And what they're going to tell you is that it's anywhere from 10 to 40 times slower than an explicitly defined class. OK, so why? What's the deal? Why is it so slow? And I would say that there are 2.5 reasons. So number one is that in Ruby, defining methods is slow. That's just how Ruby works. Two is that method missing is slow. You saw that in some cases, we're going to be setting and getting properties, and we don't have them defined, so method missing is going to be slow. And before I tell you the third reason, I just want to ask you, show of hands, has anyone here heard in, let's say, the last year or two, don't use OpenStruct because it's going to slow down your app, it's going to invalidate the global method cache? Anybody? Does this sound familiar to anybody? OK, got a couple of hands. So you've been lied to. This is no longer a problem. And the reason that I want to emphasize this is because you still see this on blog posts. You still see this, people complain about it. It's not a problem anymore in Ruby 2.1 and above. It's not going to delete your global method cache. I'd like to get into details, but we don't really have time for it. So check out that blog post by the dear departed James Golick, who basically solved the problem. So let's just bust that myth again. Ruby 2.1 and above, we can create OpenStruct. We're not going to slow down the rest of our application. However, there's still the other two reasons. So OpenStruct itself is still slow. So hey, everybody. My name is Ariel Caplan. You can find me online at AM Caplan, tweeting about programming things and increasingly about software teams and the people who are writing the code. You can also find the slides and other goodies at amcaplan.ninja. I work for Vitals. We pay people to use high-quality, low-cost healthcare. So if you're insured by a number of insurers, including BCBS of Illinois, we could be sending you checks in the mail. So talk to me about that afterwards if you're interested. If you're not that interested in money, then I still have stickers, and I would love to chat with people. So come hang out. So in order to get you the highest quality provider at the lowest cost, there's a lot of calculation that's involved. So we use a system of microservices and external APIs communicating via JSON, parse into Ruby hashes, which are fed into OpenStructs. So a lot of steps, but basically, OpenStruct is mediating the communication between our various microservices. Now, we had some performance problems. We ran some benchmarks and profiling, and we found that OpenStruct was really a problem. It was majorly slowing down our application. It was like the lowest hanging fruit to improve performance. But we really liked OpenStruct because it gave us a lot of flexibility. We could throw things in upstream and not have to do that much work downstream to use it. Stuff would just pass through the pipeline. It was really, really nice. But it was so slow. So the question became, can we build a better OpenStruct? Sadly, the answer is no. So I appreciate your time, everybody. It's been real. Troll face. Yeah, we can absolutely build a better OpenStruct in not one way, but 4. At least 4. I'm going to tell you 4 stories of how Rubyists, myself included, but also a number of others, have tried to improve upon OpenStruct. So let's begin. Round 1, OpenFastStruct. I still remember the day, March 26th, 2015. Opened up my email, checked out my Ruby Weekly, and I see this. OpenFastStruct, a faster OpenStruct? So I'm like, that's pretty cool. Let's check out the link, get to GitHub. So it is a data structure similar to an OpenStruct that it basically works the same, but it's 4 times faster. OK, that sounds pretty nice. How does it work? Well, let's check out the code. Luckily, it's not too much to understand. So the first thing that we do when you create, again, it's the same interface. So imagine like you're passing in baz and for, right? So we create our @members hash, which is the same as @table, just a different name. I guess the Arturo Herrero, who authored this, doesn't like tables, maybe. And then we update with our arguments. Update takes us down to the next method, which takes each key value pair and calls assign. All the way down on the left side, we have our @members hash. We're going to convert the key to a symbol and then assign that key value pair inside of @members. And you will notice that there are no method definitions. There's no new OStruct member happening over here. And that is a trend that's going to continue. And then we hit method missing, which is this beautiful, crazy piece of code. So we'll break it down for you. The first thing that's going to happen, it's basically trying to look at one of 3 cases that could hit method missing. So one is that we're calling .baz, and baz exists. Okay? So fetch is a method on a Ruby hash. It's probably not used enough. But if you give it a single argument and then a block, it will say, OK, so this argument is the key that I want to fetch. Let's see if that key exists in the hash. If so, return whatever the value is. And so if baz exists, we're just going to return the value, and we're done. If not, then we call the block, and we return the value of calling the block instead. So the next case that we look at is maybe it's a setter, like .baz equals 4. So, OK, so the last character is going to be an equal sign, so it's clearly a setter. And in that case, we just chop off that equal sign. That's our key, and we set that key in value, again, using a sign, just stuffing it in that member's hash. And the last thing that we do is a little bit different. OpenStruct here would just basically return nil. But OpenFastStruct, what it does is it says, OK, Baz does not exist. This is a getter, but the key doesn't exist. So we're going to create a new instance of OpenFastStruct and assign it there. A little bit different, a little weird, but not such a major difference. The key point I want to tell you, though, is that OpenFastStruct does not pay the upfront cost of defining methods. Like we said, defining methods is expensive. And it turns out that you can call method missing a few times, and it's still faster than defining a method. So it's really good when you're not accessing your properties again and again and again. So like a configuration object, this would be terrible. But for an API call where you're maybe using one attribute of the response like one time, it's great. It's much, much better. There was just one slight problem. It didn't work, at least in our app, because of the different behavior that I alluded to earlier. But I want to understand the rationale first. OK, so back to this slide, back to this documentation. It says it's not exactly like in OpenStruct. There's a couple differences. And difference number 3 is it allows infinite chaining of attributes. And there's a link to an example, so we'll follow that. So in this case, create an OpenFastStruct. We're going to call it person, person.address.number equals 4, and then we're pulling out person.address.number. And it appears 4, right? So you can have these deeply nested structures where you can just add stuff as deeply as you want, and it just works. The way that's implemented is, as we mentioned before, you create an OpenStruct, you access a key that doesn't exist, so it's just going to return nil. In OpenFastStruct, it will return a new OpenFastStruct. Well, then you can continue to set properties, go deeper and deeper, and you can basically infinitely chain these attributes. The problem is we had a lot of places in our app where we did this. So if we have our response, if.foo. Well, if that key exists, then great, and if it's not, then it's just going to be nil. So nil is a falsy value, and we're gonna proceed to the else or just skip the conditional depending on the situation. What if it's an OpenFastStruct response? Well, an OpenFastStruct is gonna be truthy, so all of our conditionals got flipped. That wasn't very good, and it broke our app all over, and it wasn't worthwhile to try to fix it. Like, it would have been easier to monkey patch OpenFastStruct than it would have been to change our app. And my point here is that, look, if you're going to make a drop-in replacement that's going to be like the same thing but better, make it better, but also make it the same thing. A drop-in replacement should be a drop-in replacement. And if there are significant ways that it diverges in terms of behavior, that's going to kill adoption. So it certainly killed adoption for us. Something to think about. So the question became, can we do better? So one option, again, was monkey patch OpenFastStruct. I didn't really want to do that. But I said, maybe we can just come up with an even better solution. And so I did. So I'm going to show you persistent OpenStruct. But we're not going to start with the internals. We're going to talk about the external API first. So in this case, you're supposed to actually subclass persistent OpenStruct. That's a standard way to use it. You can define methods on it, like any other class. We see a speak method, which is depending on type and sound. But those aren't actually defined. So now so we have our animal class. We're going to create a dog, which is a new animal with a type and a sound. When we call dog.speak, we see that those methods are being called, and it all just works fine. Standard access like a regular OpenStruct. And then you can you can also get values, right, based on dot notation, bracket notation. It all works. And here's where it starts to diverge. So if you call animal.instance methods, you look at what are the methods that are set for every instance of our animal class. So what you're going to see is that we have type equals and type and sound equals and ears and tail and nose, and all these things that we defined as attributes on animal are now and forevermore available to future animals. All those methods are already there. And it turns out it took 2 lines of code to do this. OK? If you can't immediately spot the visual difference, I underlined it for you. So instead of define singleton method, that's how we do it in OpenStruct. I literally copied over the code and changed these 2 lines. Instead of defining a singleton method, we just access the class and just define a regular method. And otherwise, it works exactly the same. So still using that internal hash and all that, but we're defining methods on the class rather than on the singleton class. So this is kind of a terrible idea. Your instances are just like randomly defining methods throughout your execution. It might even have security implications. If you have this facing user data and they start passing random keys, which you didn't expect, suddenly we're defining all these methods and your memory is overwhelmed and your server crashes. So don't do that. Not for user input, only for trusted APIs. But used responsibly, it made our app 10% faster, which was pretty good for a 2-line code change. It is about 5 times faster. This is a benchmark that is on the PrecisionOpenStruct repo. You can find that on GitHub. It's 5 times faster than an OpenStruct, still about 5 times slower than a regular class, but that's certainly a marked improvement. And it beat out OpenFastStruct, so that was pretty cool. And I know some of you are wondering, like, that's nice, but that's benchmarks. I want to see math. I want to see incontrovertible proof of the absolute superiority of PrecisionOpenStruct over OpenStruct, and I will give that to you. I will give you the information that you crave using the notation that you love, which I assume is big O. So let n equal the number of methods that you have to define. O is the number of objects that you're going to create. So if you're using PrecisionOpenStruct, it's just an O of n operation. You just define all those methods once. And if you're using OpenStruct, it's oh no, because that's the sound that you make when you realize that OpenStruct is destroying your application performance. So the goal here was not just to make a terrible pun. The goal was basically to say, like, this slide doesn't tell you anything, okay? Math is a useful framework for thinking about problems and for considering different options in the solution space. And we should use it. But we're also engineers, and we need answers that are grounded in reality. And for that, we need benchmarks. So if you're writing a library, a gem, benchmark it. If you are writing apps, which I'm sure you're all doing, and you all care about performance, I hope, benchmark them. Just benchmark everything, get in the habit. Don't trust your intuitions, require proof. Back to PrecisionOpenStruct. It's really good when you're going to create data objects with the same shape every single time, like an API call, which should generally have the same keys. It's way faster, but only in that use case. Round 3. Turns out OpenStruct still had a few tricks up its sleeve. So Eric Michael Zober tweeted out this thing, like, oh, by the way, I just went to a hackathon and made OpenStruct 10 times faster, at least for initialize. So that's interesting. But what's really mind-blowing is the amount of code that he had to write to make it happen. 0. Negative code. He just deleted that one line. That's all he had to do. Okay? We do not call any more new OStruct member in initialize. We wait for those methods to be accessed. We wait and see, are we going to actually use this attribute? And that way, we don't have to bother defining all this stuff up front. We're making an API call to the GitHub API. I just want the name of a repo. It gives me 20 other keys I don't care about. Don't define those methods. I'm never going to use them anyway. So this was introduced in Ruby 2.3. It's just now part of Ruby. And it is a dramatic improvement when some keys are never accessed. So that was a really, really cool story, I thought. Round 4 is dynamic class. So I wrote PrecisionOpenStruct. I incorporated it into our apps. They were obviously running faster at this point. Waited about a year. And I just kept having this nagging feeling like I could have done better. Like there's just more work to do to make it good. And so I invented dynamic class, had some time, and just hacked till it worked. So here's how it works. This is going to be really familiar, I hope. So you create a new dynamic class. In this case, it's a class factory, kind of like struct if you've ever worked with that. So you call .new, and then you pass it a block. And what that does is it will create a new class. It'll run that block in the context of the class, and then you can assign that to a constant animal in this case. Okay? This is exactly the same as before. We're getting and setting methods, dot notation, bracket notation. It all just kind of works as you would expect. And again, with the instance methods, they're all defined for every instance of animal. So externally, it's pretty much the same deal. But it turns out under the hood, totally different. So here's how it works. On the class level, we have an attributes method, which holds on to a set. This is all the attributes that we've defined. And then we have an add methods method, which is just going to call add a reader and add a writer. It just checks to make sure we're not overwriting any methods in case you want to explicitly define add readers and writers. And then we're going to just note, OK, we've added this attribute, so let's mark that down in attributes so we don't do it again. Now, let's tell the story of what happens when we create a new instance. So we're first going to hit the initialize method. And for every key value pair, it's going to send the key equals method with the value that you added in. So if it's like foo, it'll send foo equals with an argument of bar. Now, there is no foo equals method, so we hit method missing. And it's going to check, as you might expect, is this a setter or a getter? So in the case that it's a setter, animal.baz equals 4, right? Or we sent baz equals with an argument of 4 in initialize. So what we're going to do is call the bracket equals method with that key and that value. And if it's a getter, we're just going to call the brackets method with that value, or that key, rather. OK? Now let's see what those methods look like. The brackets method is very straightforward. It just gets that instance variable. So if it's Baz, then we're going to pull out the @Baz variable and send it back. Bracket equals is the interesting one. So we first convert the key to a symbol. We then set that key value pair not in a hash, but we're just setting the @Baz in this case. @Baz is going to equal 4. And then we check, have we already defined this attribute? If so, then we're done. But if not, then we're going to add the methods, right? That add methods method from the last slide. So this is kind of like what we did in OpenStruct, but we're just acting like a regular class. We're just using instance variables. We no longer rely on that internal hash @table. OK? And of course, the next time that you run through this, so we've already defined one animal with Baz. Well, next time when we send Baz equals with 4, we have a Baz equals method, so we're done. We don't have to go through all this, all this crazy logic. Turns out it's really fast. It's 8 times faster than OpenStruct. It's about 40% of an improvement on PrecisionOpenStruct. Still 3 times slower than a regular class, but at this point it's close enough that you can reasonably justify using it in your applications. So it's good for the same purposes as PrecisionOpenStruct, again, when you have a lot of the same keys happening again and again, but it's faster. And to me, what's really important is that internally, it works the way that PrecisionOpenStruct should have. So when I wrote PrecisionOpenStruct, I was like, OK, let's just make OpenStruct but faster. And what I learned here was, well, I don't have to make it an OpenStruct that's a little different. If I keep that API but redesign the internals, I actually have a lot more freedom, and there was the ability to make it even better. So let's kind of start to wrap up. PrecisionOpenStruct made me happy. I did some experiments, tried some stuff, found a solution, and it was really cool, and it made stuff faster. Dynamic class made me happier because A, it was faster, so that's always nice, and B, I felt it was just a much cleaner solution, and it was reimagined from the beginning without those constraints of OpenStruct. And to me, that's what I care about the most. I learned a lot from this exercise. I helped out the application I'm working on. And if people start using this because now they've heard about it, that's great, and that's awesome, and I'm so happy that I'm helping out. But to me, that's gravy, and even if all I had was that I built it, it was still worth it. So what have we learned? 5 things. Number 1, people think that the standard library is perfect. It's written by human beings. It's not necessarily perfect. There's still things to improve upon. Eric Michael Zober found one way, and I'm sure there are tons of others. 2 is that standard tools are not always perfect. If you focus just on one use case, you might create something that works better than a standard tool. If you can only have one knife, which is basically how the standard library is working, you're going to get a good all-purpose knife. But if you have to cut watermelons and you have to cut grapes, you might want to think about getting a big knife and a little knife. Right? You want to have specialized instruments for your situation. Not always, but in some cases it pays off. 3 is you have to benchmark. Okay, you might have intuitions about how to improve performance, and those intuitions might be right, and very likely they'll be wrong. And you don't know until you actually test it out. So it's best to have running benchmarks in your code that you can just hold on to, and you can watch them over time. 4th, I want to encourage people to experiment more in programming. It's a lot of fun. You learn things. And sometimes you create something that's actually kind of useful. But at the end of the day, it's worth the time invested. And if people can, it brings the fun back to programming if that's been kind of lost for you. And the final thing is, look, I had a problem, ran some benchmarks, did some profiling, found what the issue was, thought a little bit about it, created a solution, and pushed up on GitHub and Ruby Gems. There is no step in that process that anyone here could not do. I happen to do it in this case. But whatever your challenges are, you have the ability to run through those same steps and share something with the community. So don't feel like you can't do it. That's what I have for you today. Thank you to all of you for being an amazing audience. Thank you to WindyCityRails and all the organizers. Thanks to Vitals, who sponsored the work that led to this talk, and to the Flatiron School, where I learned to code, and which always encouraged us to get out there and speak. Without them, I wouldn't be here today. So again, thank you so much.